Introduction to switchgear for auxiliary power systems. Introduction to switchgear auxiliary power systems. J. Paul Geyer, PERA editor, Clubhouse Press, El Mauricio, California. Alright, content. Switchgear definition, types of switchgear, low voltage element, medium voltage element, transfer switches, regulators, instrumentation, relays, and miscellaneous devices. Switchgear definition. Switchgear is a general term for the covering of switches, interrupting device for the control of meter protect the flow of electrical devices. The components and parts include the circuit breakers, instrument transformers, transfer switches, voltage regulators, instruments, protective relay devices. Switchgears include associated interconnections, supporting enclosure structures, various configuration range and size of a single panel to assembly of those panels. Enclosures, figure 5.1, figure 5.2, contains a diagram of a typical switchgear control circuitry. Switchgear subdivides a large block of electrical power to perform the following missions: distribute incoming power between technical and non-technical loads, isolate the various loads, control auxiliary power source, provide the means to determine the quality and status of electrical power, protects the generation distribution systems. Alright, Chapter 2, types of switchgear. Voltage classification: low voltage, medium voltage switchgear equipment as used with auxiliary power system, generation system switchgear. Many installations, usually grounded metal enclosure per the Institute of Electronic Engineers. Equipment rated up to 1000 volt AC is classified as low voltage. Equipment equal or greater than 1000 volts, but less than 100,000 volts AC is medium voltage. Low voltage. Major elements are low voltage switchgear, circuit breaker for the potential transformer, current transformer, control circuit. Refer to paragraph 5.3. Related elements of switchgear include surface entrance conductor, main box, switches, indicator lights, and instruments. Surface entrance conductors, bus size as required. Typical heavy-duty conductors to carry heavy current loads. 2.2 medium voltage. Medium voltage switchgear consists of major related elements of low voltage switchgear construction. Circuit breakers employed in the two types of switchgear methods for the complex breaker tripping and our primary difference of the surface entrance conductors and main bus are typical heavy duty conductors related between 601 volt AC to 38,000 volt AC as required. 3. Low voltage elements. Circuit breakers. Either molded case or air circuit breakers are used with low voltage switchgear, usually with the air circuit breakers have drawn out construction. This feature permits removal of the individual breaker of the switchgear enclosure for inspection maintenance without de-energizing the main bus. Or air circuit breakers. Air circuit breakers are usually used with a heavy-duty low voltage application. Heavy-duty circuit breakers are capable of handling higher power loads. Molded case units have a higher current interrupting capacity. Air circuit breakers feature actuation of contacts by stored energy, which is either electrically or manually applied. According to this mechanism, is power to be put in a position where the stored energy can be released to close and open contacts very quickly. Closing tripping action is applied with the hand of a foot pedal electrically, where a solenoid provides mechanical force. Mechanical force may be applied magnetically. Air circuit breakers can be power sensor overcurrent trip devices that detect an overcurrent to the load, initiating tripping and opening of the circuit breaker. Manual circuit breakers employ spring-operated stored energy mechanism operation and release the energy resolved with a quick operation mechanism to open and close contacts. Operating speed with a not dependent on the speed and force of the operator to store the energy. Fast and positive action prevents unnecessary arcing between the movable and stationary contacts, result in longer contact breaker life. Manually stored energy circuit breakers have springs which are charged by operating isolation handle. Charging action energizes the spring prior to closing and opening circuit breaker. The spring, when fully charged, contains enough stored energy to provide at least one closing, one opening of the circuit breaker. The charged spring provides quicker and positive operation of the circuit breaker. Parts of stored energy when released during closing may be used to charge the opening spring. So this is figure 5.1, typical arrangement, metal enclave switchgear. Some manual breakers require several up-down strokes to fully charge with the spring or release and final downward stroke, either with the manual units. These no motion with the contacts until the spring is released. Electrical quick make and quick break are operated motor or solenoid. Small unit with the solenoid is used with the conserve space. Large size as AC/DC motor is used with the key with the control requirements. The lower as 4 amps at 230 volts. When the solenoid is energized, solenoid charged with the closing spring with a drive with a mechanism poised with a central and neutral point of one continuous motion motor operated mechanism automatically charging with the closing spring to the predetermined level. When signal to close, deliver the spring are released and the breaker contacts are closed with the motor with the solenoid does not aid with the closing of the stroke of the spring and supply of the closing power. The sufficient stored energy to the close of the contact under short circuit conditions. Energy for the opening of the contact stored with the closing action. Second set of springs open to contact with the breaker. Receive the trip and pull. The signal of the breaker can operate manually or maintenance by with a detachable handle. Circuit breakers usually have 2 or 3 sets of the contacts. Main arcing and intermediate. Arcing and intermediate are adjusted to open after the main contacts open to produce burning and pitting of the main contacts. Typical power. Sensitive to the air circuit breaker with a precisely control of the breaker open time with a response specified for the level of volt current. Most unit functions as overcurrent trip device with consists of solid solenoid tripper in the solid state with the components of the solid state components are as part of the power sensor provided by the size sensitive trip signals. Molded case circuit breakers. Low current, low energy power circuits usually controlled by a molded case circuit breaker with the trip elements are directly release the brake latch if the current exceed the calibrated current with the magnitude, type of the current, and characteristic curve of the molded case circuit breakers are shown in Figure 5.3. Magnetic circuit breakers have thermal bimetallic element with an inverse time current relationship to protect the sustained overload. The type of this has an instantaneous magnetic trip to the short circuit protection. Alright, magnetic trip only with the circuit breakers have no thermal elements. This type magnetic tripping agreement to trip it instantaneous with no purposely introduced time delay as current equal to or above the tripping center. They are used only for short circuit protection of motor branch circuits when motor and overload running protection is made provided by the other elements. And then it shows you an operator bus, 450 volts, 3 pH, 60 CPS. Figure 5.2 is your typical switchgear control circuitry one-line diagram. Alright, 3.1.2.3 non-automatic circuit interpreters have no on-limit automatic overload short trip elements. They are used for the manual switching isolation of the devices provide short circuit overload protection. Potential transformers. A potential transformer is accurately wound in low voltage loss of the instrument with a transformer have fixed primary with a secondary step-down voltage ratio. The potential transformer is wound with a high voltage enclosure only with low voltage leads from secondary winding brought out with the metering of the control panel. Power transformer isolated with a high voltage primary with the metering of the control panel from the personnel with step-down ratio of about 120 volts AC across the secondary rated voltage is applied to the primary that permits the use of the standard low voltage meters 120 volt AC full scale for all high voltage circuit metering and controlling ratings. Power transformer rated with the primary voltage along with the turns and step down ratio are secured at 120 volts AC across secondary. Application. The primary potential transformer connects with either line to line or line to neutral with the current flow with the winding produce the flux and core. And since the core links to the primary secondary winding, the voltage induced for the secondary circuit, see Figure 5.4. Ratio primary secondary voltage is proportional to the number of the turns primary secondary windings. This proportion produces 120 volts of secondary terminals rated with the voltage is applied to primary. Your dot convention. Dot convention used in Figure 5.5. The dot convention makes a large dot placed at one end of each of the two coils, which are mutually coupled with the current entering the dotted terminal. One coil produces an opening circuit between the terminals and second coil. Voltage measured with a positive voltage reference dotted terminal and secondary coil. So Figure 5.3 shows typical current characteristic curve. 3.3 Current transformer. Current transformer is an instrument transformer having losses for the purpose of the provide with a fixed primary secondary step down current ratio. Primary and secondary current ratio to inverse proportions. Primary secondary current turns ratio. The secondary winding has multiple turns, but the current transformer is usually either a donut winding and primary conductor wire passing through a hole of the section of the bus bar primary around, which is wound with the secondary of the bus bar with the current transformer and served with the bus being measure of the current transformer ratio is selected with the result of the 5 ampere secondary current with the primary rated current is following. See Figure 5.4. Ratings. The toroidal current transformer is rated with the side of the primary conductor diameter to surround the primary secondary current ratio of 5A ratio, but bus bars to the current transformer A are rated inside of the bus bar primary voltage, primary and secondary current ratio. Application. Primary of the current transformer is either the line conductor section of the blind bus, the secondary current up to 5 amps directly proportional to the line current. The ratio primary and secondary current is inversely proportional to the ratio primary turns and secondary turns. Alright, safety. The current transformer step down current also steps up the voltage. The voltage across the secondary is danger side when the primary is energized. The secondary current transformer must either be shorted or connected in closed metering circuit and never open a current transformer secondary while the primary circuit is energized. Alright, polarities. When the connection section there of the potential transformer and current transformer to metering circuit, the correct polarities are lead, and connections must be in accordance with a metering circuit design. The device connection wrong polarity connections will give the false reading result in the accurate data, damage, and injury. All conductors and terminations should be carry identification that matches schematic diagrams and plans used for construction and maintenance. Shows the potential IAL line, current transformer loads, line and loads, voltmeter, wattmeter, ammeter. 3.5 control circuit. Switchgear control circuits provide control power for the starting circuit with the primary move, the closing, tripping of the switchgear circuit breaker. Additional control circuit provide current control power to operate primary and secondary windings. To show current flow, the transformer polarity makes the show the instantaneous flows. Various relays indicate lights associated with the control circuit. With the control circuits are classified as either AC or DC. AC control circuits. AC control circuits usually drive the power from the source side of the circuit breaker, being controlled with the procedure applied with the main incoming line with the circuit breaker with the generator, circuit breaker with the feeder, circuit breakers. Depending on the system voltage of the control power can be taken directly from the main bus since it can be connected through control power transformer. This is the main incoming line fuse, control power transformer, control power bus, main breaker, feed breaker, load. And then over here shows the generator fuse, control power transformer, generator breaker, control power transformer, fuse, and feed breaker, load. 352. Tiebreaker control circuit. With the system of the tiebreaker with the control power with the tiebreaker, the feeder breaker with the supply through over the scheme with the control power is able to either side of the breaker is energized. An application for the requires synchronizing circuit with a running and incoming control bus for the usually supplied with a potential transformer. The transformer primaries are connected to both line side of the load side of the circuit breaker that are used in synchronizing the transformer. Secondaries are connected to the proper control bus through the contacts. The synchronizing switch through contacts on certain auxiliary relay. The synchronizing switch will use the manual operation auxiliary relay would be used automatically. Synchronizing is provided. Shows the main incoming line, the current power transformer operator, generator 1, generator 2, main incoming line fuse, your main breaker, generator breakers, and then control power transformer fuse, and feed breakers, and then the loads. Alright, 353, DC control circuit that derive the power with the battery, the source consists of the bank batteries, battery charge for the maintain with the battery at a proper charge. Battery bank can be rated at various levels ranging from 24 volts to 120 volts DC. Those circuits are required social control with a power completely independent power system connected with a DC control bus. Examples: either the primary moving starting circuit, with in some cases the trip circuit with the circuit breaker with one device other than direct acting overcurrent trip devices are used. Also, the control circuits of the circuit breaker are sometimes connected with the DC control bus. 3.6 Owner Practice. The owner practice low voltage switchgear consists of the complete menu of the program built around the equipment system, a record of the visual inspection program described by the manufacturer literature furnished with the component of the problem developed. The user should perform general troubleshooting procedure. Problem includes appropriate analysis of the records. 361 Record keeping equipment and system log sheet is important. Necessary function of the record keeping log sheet must be specifically developed to suit individual application auxiliary use. 362 Performing troubleshooting procedures. When an abnormal operation system equipment is observed, the maintenance personnel must be referred to the records interpretation, comparison, performance data, log sheet. Comparison operation should be made unequal and closely similar with addition low ambient temperature shooting is outlined with the trouble table of the following paragraphs. Use or recognize industrial practice general guide for the servicing refer to manufacturer literature. The user should refer to manufacturer literature, specific information, individual circuit breakers. General service information for the circuit breakers include the following safety requirements: do not work on an energized breaker. Do not work any part over the breaker with the test couplers are engaged. Test couplers contact with the breaker to the control circuit during testing. Spring charge breakers mechanism shall be serviced only by personal experience in releasing spring load with a controlled manner. Make the operational test. Check the breakers after the maintenance. Before it is returned to the service. Do not work a spring charge circuit breaker when it is in charge position. Shows the connected, all power connected, primary control, test power control power is still connected, disconnect, all power disconnected, Break the breaker withdrawn, ready for removal. Alright, switchgear needs exercise. Circuit breaker remains idle, either open, closed 6 months or more. Should be opened and closed several times during the period, preferably underload. The breaker is operated by a relay. Switch should be operated at this time. Services for mold case circuit breakers consist of the following procedures: inspection section, connection, signs of arcing, overheating, replace faulty connectors, tightening all connection, clean the connection surfaces, perform overload tripping test, verify automatic opening breaker to verify that the magnetic tripping feature is operating, perform circuit breaker with the overloading tripping test. Proper action breaking trip components is verified, selecting a percentage of the breaker current rating, such as 300% of the testing overload is applied separately to each pole of the breaker to determine how it will affect the automatic opening of the breaker. The refer to manufacturer's test information. Turn the breaker on and off several times. Very satisfactory mechanical operation. Alright, service error circuit breakers consist of the following procedure: install the safety pin restraint with a closing spring force. With the pin in place, contact will close slowly with the breaker manually operated. Inspection connection for signs of arcing and overheating. Replace faulty connectors, tighten all the connection, clean current connecting surface, infrared survey recommended. Inspection procedure: infrared survey should be performed when the circuit breaker is under load. Close detector, detecting overheating connections. Perform general troubleshooting breaker with refer to the following table. The problem develops if the trouble cannot be corrected. Refer to manufacturer's literature for specific information on the individual breakers. Instrument transformer require no care other than keeping them dry and clean. Refer to manufacturer literature and specific information is required. And then it shows overheating and remedy. Contacts not aligned, adjust the contacts. Contacts dirty, grease, coated dark film, clean contacts. Contacts badly worn or pitted, replace contacts. Carrying surface dirt, clean surface carrying parts, Caros, atmosphere, relocate, provide adequate enclosure, insufficient bus and cable capacity, increase capacity of the bus or cable, the butts and nose and terminal connection not tighten but do not exceed elastic limits of the bolts. On fitting, current excess of the breaker rating, check the breaker applications, modify circuit decreasing load, inductive heating, correct bus and cable arrangement, fault the trip, tripping device is not positive. The release of the tripping latch. Just replace tripping device. Warn damaged trip on unit parts. Replace tripping unit. Mechanical binding overcurrent trip device. Current binding condition. Replacing overcurrent trip device. Electric connectors for power. Sensor loosen, open, and tighten connectors. Replace electrical connectors. Loosen broken sensor with the connection. Tighten, reconnect. And tap coil tap connections. Alright, overcurrent pickup too low. Check the application overcurrent trip device. Overcurrent time setting too short. Check the application overcurrent trip device. Mechanical binding overcondition current trip device. Current binding replace overcurrent trip device. Captive thumb screws power sensitive loose. Fail safe circuitry reverts in characteristic minimum setting maximum time delay. Just power sensor tighten thumb screw and desired ground sensor comply and properly connected. Check polarity of the connections and check the continuity of the shielding conductors connecting the external ground sensor coil. Failure to close the latch, binding an attachment, preventing or resetting the latch, realign and adjust the attachment, latch out of the adjustment, attaches the latch to return spring too weak or broken, replace spring, hard or gummy lubricant, check to clear the bearing and the latch surfaces. Safety pin left, push the rod, remove safety pin, burned out, replace motor, faulty current control circuit component, replace and adjust faulty device. Alright, burn main contacts, improper contact sequence, main contacts not sufficient part of the arcing contacts part, increasing arc contact, wipe, adjusting contact operating sequence, refer to reference opening, manufacturer literature, maintenance adjustment information, also refer to paragraph 3A1G. Service circuit level above the interrupting rating of the breaker requires study with a possible replacement breaking having adequate interrupting capacity. Alright, Chapter 4, Medium Voltage Elements. Circuit breaker. The medium voltage switchgear uses the oil, air, blast, vacuum circuit breakers. Usually circuit breakers have the drawn-out construction to permit the removal of the individual breaker, enclosure, inspection, and maintenance without de-energizing the main bus. All these circuit breakers can quickly interrupt extinguishing the electric arc that occurs between breaker contacts when the contacts are separated. Oil circuit breakers When the contacts are separated in the oil, the interrupted voltage current can be greater than compared to the contact separation in air at room temperature. The arc interruption is better than oil is better in oil than in air because the dielectrical strength of the oil is much greater than air. Also, arc generates hydrogen gas from the oil. See Figure 5.9. The gas is superior air to cooling medium. Usually, the contacts of the arc are enclosed in fiber arcing chamber. The exhaust ports on side to side to increase one side to increase the capacity. Air circuit breakers, arc extinction, high pressure air blast, and another method quickly interpreting extinguishing electrical arc cross blast type of breakers, usually in a medium voltage switchgear. A cross blast breaker with an arc chute with a one splitter with the insulating fin with the functions are air barrier. See Figure 510. The arc is drawn between the upper and lower electrodes during the interruption of the blast. For the high pressure air is directed across the arc, pushing the arc against the splitter. The arc is broken and current zero carrying downstream. Should fiber walls, forms, arcing chambers, stationary contact exhaust ports, blast of hydrogen gas fiber, arc splitters, moving contact, and arc. Alright, vacuum circuit breaker, vacuum arc integrating the newest quickest method of the arc extinguishing electric arc with the type of the breaker, Figure 511, oilless, fireproof, nearly maintenance-free. Surface life is very long. Arc interruption rapidly with the usually in first current 0. High electrical strength of the small vacuum gap contributes to rapid interruption of the arc. Short contact travel that permits mechanism to part the contacts much faster than oil breakers. Warning: mechanical indication opening may not be true. Always make sure no voltage exists in the load or line side before performing any work. And Figure 510 shows the air blast arc interrupter. Orifice plate, high air pressure, air blast, arc upstream, arc electrode, downstream, arc electrode, low air pressure, orifice plate. Our potential transformers are accurately wound, low voltage loss instrumental transformers having the fixed primary, secondary step down voltage ratio. Power transformers mounted with potential transformers mounted with a high voltage enclosure only with low voltage leave secondary winding are brought out of the metering of the control panel. The power potential transformer isolates the high voltage primary with the metering control panel from personnel. The step down ratio produces about 120 volts AC across the secondary. Rated voltage is applied to the primary that permits the use of the standard low voltage meters 120 volt AC full scale for a high voltage circuit metering can control. Ratings: potential transformers are usually rated at 120 volts in the secondary circuit. And this shows a picture of a cross-sectional vacuum air interrupter. Are your current transformers an instrument of the transformer having low losses with the purpose of to provide fixed primary and secondary step-down current ratio? Primary and secondary current ratio inverse proportion of the primary secondary turns ratio. Secondary winding has multiple turns. Current transformer is usually either toroidal donut type winding primary conductor wire passing through a whole unit section primary bus bar primary around which is wound with a secondary inserted with the bus run. The current transformer ratio is selected the result in 5 ampere secondary current with primary rated current in the flowing. Current transformers are usually rated at 5 amperes in secondary circuit. Control circuit. Switchgear's control circuit with a medium voltage are functional similar to those used in low voltage system. The controls are similarly classified as either AC or DC. Owner and practices. The owner practices medium voltage switchgear consists of a complete maintenance program with a built-around equipment system rack with a visual inspection program described with the manufacturer literature furnished with a component of the problem developed. The user should perform general troubleshooting procedures. The program includes appropriate analysis for the record 451. Record keeping equipment and system log sheets are important necessary function of the record keeping. Log sheets must be specifically developed to suit the individual application auxiliary use. Troubleshooting. Performing troubleshooting procedure with the abnormal operation system and equipment is reserved for the maintenance personnel must then refer to records of the interpretation comparison with the performance data log sheets. Comparison operation should be made with under equal and closely similar conditions of load, ambient temperature. General scheme of the troubleshooting is outlined in the following paragraphs. Use recognized industrial practice general guidelines serving referring to manufactured literature. Users should refer to manufactured literature and specific information on individual circuit. General surface information circuit breakers include the following safety requirement. Do not work an energized breaker. Do not work any part of the breaker and test couplers engaged. Test couplers connect the breaker to the control circuit during the testing. Maintenance closing devices. Switchgears are not suitable for closing in a live system. Speeding and closing is important, and speed and opening in a wrench or other maintenance. The tool is not fast enough. Before working on the switchgear enclosure, remove all draw-out devices such as all circuit breakers, instrument transformers. Do not lay tools down on the equipment while working on it. It is too easy to forget a tool was when closing an enclosure. Alright, switchgear needs exercise. Circuit breaker remains idle with either open and closed for 6 or more months. It should be opened and closed several times during the period, preferably under load. If the breaker is operated by a relay or a switch, should be operated at this time. Alright, service circuit breakers using insulation liquid required special handling. Elevate the breaker with a breaker on the insulation inspection rack and tank it from the scope of the contact. Insulating liquid, usually used with a circuit breaker, is a mineral oil. Equipment using liquid to contain polychloride biethanols or PCB may be still being used. The polychloride biethanols are carcinogenic, non-biodegradable. Some restrictions to their use. Apply silicone insulation liquid can be used as suitable. The polychloride biethanols, when authorized by an engineer, special handling is required. Polychloride biethanols are used in any of the equipment. Refer to the Title 40 CFR 761 for polychloride biethanol detail. Polychloride biethanols are power solvent. Handling disposal information, special gloves, check the condition, alignment. Just the contacts, verify that the contacts surface the barriers of the firm, even pressure. Use fine foul to address rough contacts. Replace pitted and the burned contacts. Wipe clean all parts normally immersed in liquid. Remove traces of carbon that remain after the liquid has drained. Inspect insulating parts for cracks. Other damage requiring placement. Test dielectrical strength of the liquid using a 0.1 inch gap to a 1:1 and 1.1 inch diameter disc terminals. If strength is less than 22 kilovolts, remove the filter. Replace with a new liquid having dielectrical strength of at least 26 kilovolt filter liquid whenever inspection shows excessive carbon. Even the dielectrical strength and satisfaction because of the carbon will deposit the insulating surfaces, decreasing the insulation strength. Liquid samples should be taken in large mouth glass bottles that have been cleaned and dried with a benzine. Use a cork stopper with a spout with draw test samples from the bottom of the tank after the liquid has settled. Samples should be in the tank proper or not for a valve with a drain pipe. Periodically remove the liquid of the tank. Wipe the inside of the tank and the tank lining barrier with the remove the carbon. Inspect with the breaker operating mechanism, loose hardware, missing or broken cotter pins, retaining rings, and check adjustment, readjustment when necessary. For the manufacturer's instruction book, clean operating mechanism. Then lubricate air magnetic type breakers. Refer to manufacturer instruction book before replacing the tank and the operator breaker. Slowly maintenance closing device. Verify there's no friction binding to prevent the slowdown in its operation, and check the electrical operation. Avoid operating the breaker any more than necessary when testing is without liquid in the tank. It's designed to operate liquid, and mechanical damage can result with excessive operation without it. When replacing the tank filled with the correct level with liquid, be sure of the gaskets on damaged tank nuts and flange nuts of the gauges and valve are tightened properly to prevent leakage. Or service air blast type circuit breakers. Circuit breakers should be served with the test exercise calibrated at intervals not exceeding 2 years. Refer to AR 42043. Withdrawal the breaker from the housing for the maintenance. Circuit breakers are designed to perform up to 5,000, 3,000 operations for 1,200 amps or 200 amp breakers, respectively, without major overhaul. More frequent services may be necessary. Operating conditions. Severe inspecting servicing should be performed after clearing operation. Refer to the instruction provided by manufacturer. Wipe insulation part. Include bushing inside of the box barrier to clean off the smoke and the dust. Repair moderate damage to the bushing, insulating by sand, smooth, refinishing, clear insulation varnish. Inspect alignment and condition, movable stationary contacts. Check for their adjustment as described. Manufacturer's instruction book. Check the alignment and close the breaker with a piece tissue, carbon paper between the contacts. Examine the impression. Do not follow the type of the contact with the contacts have within roughness with the surface that may recurrent as well as smooth contact. Remove large projections or bubbles caused by unusual arcing by filing. When filling a touch for the keep of the contact with the original design. That is, if the contact line type of the keep of the air with the contact linear. If the ball and point type, keep the ball and point shaped out. Check the arc chutes for damage. Replace damaged parts. When arc chutes are removed, blow out the dust and loose particles. Clean silver-plated breaker primary disconnecting device. Alcohol, silver polish. Refer to the manufacturer's instruction book. Lubricate the device. Apply with a thin film over the approved grease. Inspector braking operating mechanism for loose hardware, missing broken cotter pins, retaining rings, and examine the cam, latch, and roller surfaces for the damage excessive wear. Cleaning and re-lubricating operating mechanism. Refer to manufacturer's instruction book. Lubricate pins and bearings not disassembled. Lubricate the ground, polish surfaces of the cam and the roller, latches, props, or any other bands and bearings that are removed for cleaning. Check the vapor operating mechanism to adjust and readjust the described manufacturer instruction book. Adjustment cannot be made with a specified tolerance. Successive wear is needed, but the complete overhaul is indicated. Check for the control device for the freedom operation. Play with the contacts badly worn, burned, inspection breaker control, wiring tightness, connection. After the breaker has serviced and operating is slowed with the closing device, check the absence of the binding friction. Check the contacts move the fully open, fully closed position. Check electrical operating operation using either test cabinet or test couplers. Our service of vacuum circuit breaker. The breaker has primary contact with the clove of the vacuum containers or flasks. The direct inspection replacement is not possible. The operating mechanism is similar to the other medium voltage circuit breaker with the general outline. Same with the maintenance work with the enclosure of similar. Figure 511 shows a breaker with the primary electrical contact is both. The stationary contact is solidly mounted. Move the contact is mounted in the enclosure with a bellows. Seal of the contact erosion is measured by a change in external shaft position after a period of use. Solve the manufacturer's instruction book. High voltage supply of the during test as produced with X-ray emissions. Personnel performing high pot tests may be stand behind protective shield during testing. Condition of the vacuum is checked with a high pot test applied with every maintenance period. Consult manufacturer's instruction book for test procedure for the contact of the vacuum circuit. Breaker cannot be cleaned, repaired, or adjusted. The vacuum bottle is usually replaced if the test indicates a fault. Chapter 5, Transfer Switches. Alright, 5, Transfer Switches. During actual threat and power failure, transfer switches are actuated to transfer a critical electrical load circuit from the normal source of power to the auxiliary emergency power source. The normal power is restored with the transfer switches automatically retransfer. The load circuit of the normal supply must be transferred manually. Voltage and frequency sensing relays are provided to monitor each phase of the normal supply. The relays initiate load transfer when there is a change in voltage frequency. Any phase outside of the predetermined limited additional, the relays initiate retransfer of the load to normal source as soon as voltage is restored in all phases beyond the predetermined pickup value of the relay. The transfer switch obtained by the operating current from the source of the which the load is being transferred. 5.1 Type of transfer switch. There are two types of transfer switch: electrically operated, manually operated. Electrically operated transfer switch also become an optional bypass function. Electrically operated switches obtain the operating current from the source of which the load is being transferred. A separate voltage supply is used for some of the systems. Electrically operated switches consist of three functional elements: main contacts to connect, disconnect to the load, and from the source of power sensing circuit with constantly monitoring the condition of the power source provide the information necessary for the switch-related circuitry operation transfer mechanisms to make transfer from the source to source. Circuit breaker type. Circuit breaker transfer switches are mechanically held. The devices using the two circuit breaker with usually the breaker handles are operated by the transfer mechanism provided with the double throw switching action connecting one circuit terminal either to others. The transfer mechanism operated electrically by a unidirectional gear motor. Motor integral speed reducing gearbox or bi-dual motor operates all parts and positive contact at all types. These switches can also be operated manually and have provisions disengaging the generator when necessary. Alright, neutral position. Some transfer switch have the neutral position. Their switches mechanically electrically interlock, so with the neutral position is not possible during electrical operation. Also, load circuits cannot be connected and switched to normal emergency source simultaneously, whether they switches operated electrically or manually. Contact type. Transfer switches mechanically or electrically held contactors with a command load bus. Switches are mechanically electrically interlock with a neutral position. Not possible under normal electrical operation. Additional load circuits cannot be connected normal and emergency source simultaneously. Bypass function. Electrically operated transfer switch can be provided with a bypass function. Bypass function manually transfers the power around with the automatic transfer switch. Electrically operated switch can be tested and removed with a repaired, and bypass function may or may not cause momentary interruption load depending upon the manufacturer. Bypass is purely a manual function, therefore, if the source of the bypass is connected failed by the bypass must be manual transferred. Alternating source. Bypass transfer switches are only used in the most critical applications where the load is operational continuously. Alright, manually operated manual transfer switches are mechanically held with a device using the two circuit breakers operated by hand. Handle all parts of positive contact at all times. Switches are mechanically interlocked. It's impossible for the load circuits to be connected. Normal emergency source simultaneously. Manually operated transfer switches are available. Single dueling operating handles. A common operating mechanism across two breakers. Mechanical contacts connects and operates the breakers. 5.2 Operation transfer switch have two operating modes: automatic and non-automatic. Automatic transfer switch have high voltage sense relays for each phase. These sensing relays connect with the normal power bus behind the protecting device. Alright, the transfer switch is connected with a normal power source on the normal condition sensing relays detect with a sustained drop of the voltage. The normal power source of the relays automatically source. So the auxiliary generator with the transfer switch operates used in a sustained drop in voltage in phase of the normal source, approximately 30% drop delay out about 2 seconds to the start of the auxiliary generator. 5212 when voltage and frequency. The auxiliary generator rated the value of the normal power source still below normal. The automatic control will transfer the load to the emergency source. Upon return from normal power, within 10% of the rated voltage, all phases after the preset time delay switch automatically transfers the load to the normal source. The auxiliary generator will run under load for about 5 minutes after transfer before it shut down. The controls automatically set with the next emergency start. Usually the controls of the power transfer system have the test switch. These prevent simulation failure of the normal power source of the test transfer switch operation. Power transformer and power transfer indicators provide most automatic transfers. System indicate currently used power source, usually an amber light marked with emergency power. So the system on the emergency power when illuminated, white light marked normal power show the system is receiving power from its normal source when illuminated. Alright, your non-automatic, the non-automatic operation operator needs to manually transfer from the emerging power source. The operator can usually make with the transfer opening and closure. The transfer is usually based on its instrument indication made by placing transfer switch required emergency or normal position. Power transfer indicators are provided with the operator amber light emergency power show the system on emergency power when illuminated. A white light normal power show the normal system receiving power from the normal source when illuminated. The operator is usually provided with the override switch with the bypass of the automatic transfer control. The feature permitted with identify connection with the emergency power source regardless of the condition normal power source. Owner practices for the transfer switch consists of the complete maintenance program built around the record's visual inspection. Programs appropriate analysis of each record keeping. Equipment system log sheets are important. Necessary function record keeping log sheets must specifically develop and suit auxiliary use. Troubleshooting use recognized industrial practice for general guided transfer switch system. Troubleshooting the system circuits that are not performing according to the specification or to be required performance level should be accomplished as far as the refer to engineering data drawings pertaining to a particular plant. The user should refer to manufacturer literature with specific information. Individual transfer switches. Perform general troubleshooting transfer switches and problem develops. Refer to manufacturer literature specific information. Usually all of the control elements renewable in the front switch without removing the switch for the main closure without removing the main power cables. Alright, 6. Regulated voltage regulator maintains terminal voltage of the alternator generator. The predetermined value of the voltage control of the regular strength with the electromagnetic field of the producer. The alternator exciter voltage regulator automatically overdrop the voltage. Alternator change field excitation automatically as it varies with load. Type of the regulator. The type of the regulator's voltage are electromechanical static voltage static exciter. Electromechanic voltage regulators. These regulators use a servo control system. 3 principal elements. First is a voltage sensing device. The voltage regulating relay with the device monitors output voltage sensing sends a signal to the control circuits. Second is an amplifying section with or without time delay, which amplifies the voltage signal. Third is a motor drive with which responds to the signal moving a tapping charger indicating induction regulator in the direction to correct the voltage. Static voltage regulators are usually a high static voltage sensor instead of a voltage regulating relay. Alright, operation voltage sensor output is applied with a solid state with a magnetic amplifier discriminator for the circuit and signal thereby provide with the changing alternator output to raise and lower the voltage. As required, the voltage zones between initiation, raising, and lower control action when it's called with the voltage band. With the band must be more than the minimum correction obtainable through regulator hunting with it will occur. 6122 accessories include either thermal delay relays, resistant capacity networks to provide the time delay, load trend correction, time delay, retard signal unit accumulated with the time outside of the voltage limit. Less accumulated time inside of the voltage limit exceed the time delay setting. Your static exciter regulator supplies the alternator field with a DC voltage output line obtained by 3-phase full wave bridge rectifier. Alright, operator. Small part of the alternator outputs goes with the regulator with the meters with the rectified DC voltage back to the exciter field windings. Rectifier DC voltage produces a 60 cycle ripple The ripple gets in the field windings. Electrical discharge from the winding shaft can occur. The filter can be used to reduce the ripple discharge caused by because copper of the field windings metallic shaft act like a plate of the capacitor. This action may result in shaft beer pitting and eventually with a bearing failure. System exciters manually manufactured as subassembly and assembly wired at a manufacturer's plant, usually in one or more silicone rectifiers to convert AC voltage to DC. Subassembly usually includes a regulator and a filter. Refer to the manufacturer literature test and adjustment details. Our accessories include either thermal delay relays, resistant capacitor networks to provide a timely delay of a load train correction, suppression circuit. Ripper filters usually provide with a bypass ripple of the ground before it gets to the generator field. Owner practice. Owner practice of the voltage regulator consists of the complete maintenance program of the built-around records. Visual inspection of the program includes appropriate analysis of these records. Record keeping equipment. The system log sheet that is important for the necessary function of record keeping. The log sheet must be specifically developed to the suit auxiliary use. 622. Troubleshooting. Use recognized industrial practice. The general guide for servicing refer to manufacturer literature specific information. Individual voltage regulator troubleshooting procedure including the following. Check voltage compliant with the manufacturer's specification. Check for loose, insecure electrical connection. Check for the correct setting. Refer to manufacturer lecture. Check for the for unregulated voltage. Refer to manufacturer literature. Check with the enclosure shall be weather tight. Check with the motor for the proper operation. Loose connection clean. Lubricate weight is required for the manufacturer literature for details. Our voltage regulators are associated equipment normally mounted with the switchgear equipment and they interconnect with the different components of these proper operation troubleshooting voltage regulator equipment. Depend on these different components to perform the procedures in the following table. Alright, watt hour meter inaccurate. Meter may be dirty or damaged. Install new meter. Return faulty meter. Return depot for repair calibration. Faulty wiring and connection spec to repair necessary. Watt meter hour meter fails to register. Blow potential transformer for the broken wires. Other fault connection. Running known blow fuse. Check wirings. Repair as required. Wedge or block accidentally left the time on test or expense. Remove the wedge block. Verify that the meter is in good operating condition. Damage control instrument transfer switch or test block. Burner pitted contacts. Dress and clean. Burns contacts. Replace with new contacts as necessary. Relays failing to trip breakers in proper setting. Adjust setting to correspond with circuit condition. Refer to manufacturer's instruction. Dirty, corroded, tarnish, and contacts. Clean contact with a knife with the tile. Do not use emery cloth or sandpaper. And then Alright, contacts improperly adjusted. Adjust contacts very proper. Wipe action. Open short circuit relay connection. Check and verify that the voltage is applied with the current is passing through the relay when the question. Improper application of the target holding. Verify the proper tripping action of the target and holding coil. Faulty and proper adjustment of the timing device of the bell of the oil film contact. Clean adjust. Induction disc type check for mechanical interference. Refer to manufacturer literature. Noises due to vibration, loose bolt with nose permitting an excessive vibration, tighten proper torque value, light limitation cones, transformer reactors, tighten loose nut, core clamps, proper torque value connection, overheating, increased current due to overlead condition, increase the current capacity, increase the number of size of the conductors, remove the excessive current from the circuit, connect the bolts not too tight, tighten all the bolts not to proper torque value, Failure and function of all the instruments and devices having potential winding, loose nut binding screws with broken wires at the terminal, tighten all loose connection, proper torque value, repair broken wire, circuit broken, blown fuse, potential transformer circuit, renew blown fuses, open circuit, potential transformer, primary, secondary circuit, repair open circuit, check for the entire circuit with the continuity in good condition. Breaker fails to strip. The mechanism binding is sticky called with lack of lubrication. Lubricate and breaker mechanism refer to manufacturer instruction. Mechanism adjust all mechanical devices, toggle stops, buffers, opening springs, according to manufacturer instruction. Failure latching device. Examine such latch to replace latch if worn or corroded. Check with the latch wipe and adjusting in manufacturer's construction. Damaged trip coil. Replace damaged trip, damaged coil. Blown fuse circuit control, replace blown fuse, faulty connections, repair faulty wiring, tighten all binding screws to proper torque value. Oil contaminated, carbonization to many of the operations, drain oil filter clean, replace fresh oil, clean inside of the tank, all internal parts of the breaker, refer to manufacturer's instruction. Condensation due to atmospheric conditions, same procedure as above, overheating, eliminate cause of overheating. Alright, chapter 7, instrumentation. Switchgear instrumentation based on the complexity of the complete system. They include all combination Canadian road cording, metering instruments, potential current transformer, are used to isolate instrument circuit with the power circuit with usually secondary winding potential transformer rated at 120 volt. Current transfers output at 5 amps to instruments included with indicating recording type application information related to instrument transformer application is covered in the technical commercial literature. Voltage values are indicated with voltmeter. Current values are indicated by ammeter, and power values are described in watts bars as a power factor. Watts and kilowatts units electric power indicated with the wattmeter. Vars are voltage amp relay. Voltage amp resistors or kilovars. Reactive power obtained multiplying effect of the value current effective voltage and sin angular phase during between current and voltage. Power factor ratio, active power with the apparent power displayed with the power factor meter scale, usually graduated in percentage power factor. Frequency, alternating current is indicated with the frequency meter scale is usually graduated at 50 to 60 hertz. Speed, rotational speed with the primary mover indicated with the tachometer revolutions per minute. Generation system covered in here and usually with an impulse tachometer included. Inductor eddy current type of the tachometers use magnetic pickup the spent seed. Temperature, several temperature values including coolant, lubricating oil, and exhaust are used required to assure safe primary mover operation. Each value is monitored. The sensing device remote indicator thermometer. Sensing device can be thermocoupled combination sensing bulb capacitor tube. Thermocoupler consists of a pair of electrical conductors, each with a different metal with a joint with each adjacent to the temperature. If you measure thermal electrical metal force is produced with the junction in the conductors. Each conductor is connected to the voltmeter, which measures the indicated thermal electrical magnetic force. The sensing bulb and the capillary tube. The sensing bulb and the capillary tube contain with a specified amount of liquid or gas whose pressures vary with the temperature. With the variation appears on the thermometer representation temperature, coolant, oil, and exhaust. Pressures in primary movement indicate the sensing device remote gauge of the board and tube. Whose variation appears on gauge representation lubricating other pressure. Other pressure values may be shown on a system instrument panel depending on the type of the primary for the overall system requirements. These pressure valves include starting air, turbo boost, scavenging air, exhaust manifold, and fuel gas gauges. Mirrors are used for the indication of the required fuel level. Various methods use the fuel level. The measurement fuel underground storage tank that can be measured immersing calibrated dipstick into the tank for day tanks. Glass sight gauge and the floated actuated gauge can be used to measure quantity of liquid fuel. Remote indicators, pneumatic and electrical hydraulic devices are also used. 729 running time. The amount of time the auxiliary generator system operates and required part of the system record. Keep the time is usually recorded in digital measuring device counter located in the system instrument panel. User counter is used with electrical electronic circuit. Electronic system usually AC synchronizing motor is shared to counter. Like auxiliary motor and counter depends on the frequency generator output voltage. Electricity system also records the operating with a time digital measuring device. The system measures the time and the counting of the number of cycles produced with the frequency of the generator output voltage. Counter indications are proportional to frequency versus time. Alright, 8 relays, and we'll see how much money we got to read. So